Hello everyone, in this tutorial we will explore custom modules, a robust and intuitive way of building neural networks in PyTorch. We will build more complex neural models in the next section and thereafter, but for now we'll simply use it to build our simple linear model just to learn how to do it. Now that you're more familiar with the basics, the method in which we're currently going to implement model construction grants you more freedom and is much cleaner and more intuitive in its implementation. So on a new collab notebook, I've already went ahead and imported Torch, and inside of a new cell, we start by creating a new class, which I will call LR, as in linear regression. And I know that we haven't covered classes in the Python crash course, so if you're unfamiliar with them, we can go through them now very quickly as we go along. But essentially, we will use this class as a template, as a blueprint for our model's construction. Generally, it is a template for creating new objects, new instances of our LR class. Our class will be immediately followed by the init method, which can be written as def init. Ensure that you use the double underscores before and after the method. If you come from another programming language, for example, ES6 JavaScript, this would be known as a constructor. And so we use this initializer, we use this constructor to construct, to initialize new instances of this class. The first argument for our initializer is usually self, where self simply represents the instance of the class, the object that's yet to be initialized. And then after self, we can add additional arguments. Our choice for these arguments is dictated on the basis that we are using this class to initialize a new linear model instance. If you look back at the previous code, initializing a linear model requires that we have an input size as well as an output size. In this case, 1 and 1 for both, since each input will produce one output. But we will be more general inside of our constructor. That is, the arguments passed in will be input size and output size. Whatever input size and output size is passed in as we create our instance. And perfect. That is all. Now to create a linear model, to access our linear class, we first needed to import torch.nn. Let's do that again. We will import torch.nn, but this time let us do it as the alias nn. We will use inheritance such that this subclass will leverage code from our base class nn.module. Module itself will typically act as a base class for all neural network modules. In this case, the linear regression model class will be a subclass of nn.module, thereby inherit methods and variables from this parent class. And when dealing with class inheritance, one should be mindful of calling super.init, which simply allows for more freedom in the use of multiple inheritance from parent classes. Alright, now this is just boilerplate code that you always need to write to create your custom class. And now, having performed all the necessary steps to inherit from our parent class, we will declare self.linear, which represents the instance of the class, the object that we intend to initialize, and it will be set to nn.linear, as we've done before, accepting both the input and output size that's being passed in. Input size and output size. Great, we finally finished our initializer, which we can now use to initialize a new linear model. We can do this by setting. We seem to have made an error, and that is because I should run this before running nn.module. Okay, back to it. We will initialize a new linear model, an instance of this class. Model is equal to LR, and we can pass in 2 arguments into the initializer as clearly shown. As before, we pass in an input size of 1 and an output size of 1 as well. And there is our linear model. You can now seamlessly create more linear regression models to your heart's content. we will stick with 1 and print out the random weight and bias values that were assigned to it from nn.linear. We do this by printing model.parameters, and we will print it as a list in order to better see our results. And before making any conclusions, as done before, we will seed our random number generator to see consistent results with torch.manual seed, and it will contain the same seed as earlier, 1. All right. And our weight term equates 0.5153, and the bias term negative 0.4414, as before. And now recall, to make predictions, we make use of the forward method. And conveniently, we can define the forward method inside of our class such that the method can be accessed for every instance of the class. So we write def forward, once again, the first argument being self, and arguments thereafter being the ones you need to actually pass in. In this case, we pass in the input x. All right, and now forgot my colon. And now the prediction pred will equal the prediction that comes out of x being passed into our linear model, self.linear. Let's not forget our brackets. And we will return the prediction, return pred. Running this cell and back here. We can now use this method for any instance of our class. In this case, we will use it for our model. So we write model.forward, and into it we pass in a tensor as we have always done. So we write x is equal to torch.tensor 1.0. Ensure that this is a float, and into our forward function, we put the x and print the result. Print model.forward x, like so. And it outputs the appropriate prediction. We can try this for 2 values of x, 1.0, 2.0, wrap them up in a single bracket. And yet it's consistent, as it now makes 2 predictions based on 2 independent variables, such that for every 1 input, there is 1 output. Very well, you should now have become very comfortable in making predictions using the linear class in an object-oriented programming approach. Going forward, this is how we will approach model initialization in this course. The next step before we conclude the linear regression section is to actually train our model to develop new weight and bias values based on previously labeled data, rather than just working with the random parameters. We will do that going forward.